Okay, I'll be going over the critical assessment of features and usability for each tool that we saw on this video. First, we have coverage PY, and this is mostly for Python code. It has three different reporting tools, and its execution monitors what lines of code are being executed, and then we have analysis. It determines what lines could have run, and then finally has the reporting. And this is the coverage number, an indication of missing execution based on the analysis. It's a very useful tool. The main critic that we would have about this feature is that it can only mostly be used on Python, which is something that a lot of code bases have not been implemented in. And it's also in terms of usability, if we take into account the coverage and the amount of applications that can use it, that would be the downside of it. Then we have OpenClover. This is a tool that it's mostly used for Java, and this was a pretty useful tool to use. It has like around 20 metrics, and it shows you like graphics of what kind of code is being covered every single time that you do a test case. It is very usable and very easy to implement compared to JCoco, which is a tool that we had the most trouble implementing, mostly because there's not a lot of documentation and not a lot of um, online help that can help you set up for your own particular project, especially if it differs from the templates that we see on the tutorials. And it's in terms of usability, we would say that it's mostly it's very difficult to use, so it doesn't help any programmers or coders in our case to easily identify what kind of problems we're having with the code, since it's very difficult to set up and also very difficult to interpret in terms of metrics. And then finally, we have IntelliJ. IntelliJ, I would say it's very usable. It's also very straightforward, as the same as OpenClover and coverage. So in terms of usability, I would say it's on the same standing as OpenClover, since it's very easy to implement, easy to use, easy to interpret. So it's really good usability. Thank you.
Okay, so I will be covering coverage.py, which is a tool for measuring code coverage of Python programs. It basically monitors which parts of the code have been executed and then analyzes the source to identify code that could have been executed but was not. So, for example, right here, I do have two methods on app.py, which is the Fibonacci series, and down here, the factorial method. Here, I do have two tests, each for its corresponding methods, one for the Fibonacci, one for the factorial. Once we type in the command for the coverage.py, which begin with the coverage run, and then the name of your file. Then we move on to the report of it. And here we see that only 25% was basically ran, meaning that here we didn't pass through any valid methods that would run this logic right here. In order to do that, I have a calling of a method for each of the methods. So let's just do the Fibonacci. And here you see 70% has been done. That's because this is 70% of the code. And for the rest of the 30% would be for the factorial method, which we have these two other. And let's give it a run. And boom, 100%. And of course, there's always the coverage HTML. And I forgot I already had it run. And right here, I'll open it on Firefox. Whoops, open 3. But here you can see that all these green lines have been ran, and none of it has been missing because we've used this. In order to use the actual testing methods, we can use this coverage run plugin, which is called PyTest. So I already have that one installed as well. All we need to do is equal this to app. Whoops, sorry, typed it in wrong. Let me double check. It's actually double dash. Yeah, that's. Oops, typed it in wrong again. Okay. So now we see not the actual like method calls, but rather this right here.
Hello, this tool is OpenClover and we'll be going over what it does. It's mostly a sophisticated code coverage tool for Java and Groovy, and it allows to identify the most risky code and also the untested areas of your code. Since we have 4 other tools, I'll be briefly going over what it does. So I already imported the project and the kind of code base that we're going to be using. We're going to be using the project BPS, which was obtained from ModelMine, and we have been using it for the past 2 assignments. So as we can see over here, after importing everything, we have all the directories and all the possible test cases that could be over here. So in this package explorer, what we're going to do is right click on it, and then you're going to go to Clover, and then here you're going to have an option that says enable for this project. Since I already enabled mine, it's only allowing me to disable. So after like some minutes, it's gonna show you all the folders with the little clover on that minute, meaning that the tool is already being enabled and you're gonna be able to see the different windows. We have 4 different tools or main functions out of it. We have the coverage explorer, which is it's mostly gonna show you the hierarchy and all the classes that you have over here. If we had any test cases here, we would be seeing like a percentage of test cases that are being covered out of it. But since we don't have any test cases in this code base, we mostly see the red. Um, this is a bad code design, and this is something that the people working on the code base should take into account of. If you had like any passing test cases, you would have a green, and then you would fail to have yellow colors over here. And then you have the test run explorer. Here you see all the tests that you have right now, and all the tests that are being run, and then you would have the kind of classes that they're being associated with, and the kind of contribution. So what percentage is it actually covering? Then you have the test contributions, and this is where you have all your test cases, and you're able to see the hierarchy of test cases. And then finally, you have the dashboard, which is like a summary of everything. So what kind of coverage you're having. It says like 4 classes and then 53 elements in this case. And then you have the test results, and then what kind of complex packages you have right here. And this is done by identifying the number of files you have in those folders. So as you can see here, we have the project risk and then the least tested methods. Since we don't have any test cases, we're not able to have like a good view of how the code base is actually covered. So it would be very vulnerable to cyber security attacks. Mm.
So I will be covering JCoco, which is just an extension so that code coverage can be found. And code coverage is just the percentage of code which is covered by automated tests. And I will be using this as the target code base. So here I have 2 methods, start and stop. And then here I do have my 2 test cases to test those 2 methods. And before you can even run JCoco, you have to have these certain plugins as well as properties. And that's just taken from this website right here. And then this is what JCoco produces. So as you can see, main and code coverage have 0% because those were not the ones that we were focusing on right now running JCoco. It was mainly start and stop. And then JCoco also gives you other information, for example, the complexity, which tells you how many more test cases you need to run in order to have more code coverage.
Okay, so I'm going to talk about some of the things that we can do with the IntelliJ code coverage. In the file that I created right here, it's just a simple testing file with a testing method. We can do this with different kinds of tests. We can make different equals testing and everything. The one that I created here is going to fail just because the test that we created doesn't really test anything. And the problem for this is that we didn't have too much. I didn't have too much information on the code base that we were testing, but we did different tests that we can go over. So in the following snippet, we can show that we can go to a certain code base, and inside this code base, we can run all the tests that are within this code base. When we do this, we'll be able to see all the test cases that are currently going on. And the advantage that we have with this is that we can get rid of test cases that have already passed so that we can see the ones that are giving us problems. Sometimes in this little section here, we can see how many of the test cases have gone through, and then this is just different information on all the test cases that is going on. This is just more information. Some of the things we can also see with this is this is the number of tests. This is just kind of like general idea, but this is the number of tests that have been done, and the tests that have been ignored, and then the same here with more information going on. We can track some of the running tests that are going on. When we do this, it'll take us to like kind of like this screen where we see all these tests, and one of the also important features is that we can see the test that didn't pass, so we can go straight to that test and kind of figure out what's going on. We also have these where like we have our tests and everything. We have more information on all the tests. So if we have like these certain tests that we've made, these 6 tests, then we'd be able to go in and say all of these tests pass, and we have like a confirmation that all of these tests passed. There's some warnings, but that's just general information of the test. And that's pretty much it for the IntelliJ